Good evening, everyone. My name is Sitong. So everyone in Japan call me Sito. So I became a Qiskit Advocate in this summer, and I would like to do like short self introduction, and also talk about my experience of using Qiskit and also my experience in quantum computing. So this is me, and actually I am an international student from China, and this is my 5th year in Japan. So I speak Chinese, which is my native language, and I also speak English, and I speak some Japanese. So I have graduated from Keio University, Faculty of Environment and Information Studies, and I'm currently a second-year student at Keio University, Graduate School of Media and Governance, and I belong to the 先進的量子 architecture 研究 group. I belongs to the Advancing Quantum Architecture research group, which is a research group study quantum computing, and my research field mainly lies in quantum computing, especially about quantum error correction, quantum compilation, and quantum machine learning. So, and this is my Twitter account. So, long time ago, it was all about quantum computing, but now if you check my Twitter, you'll find it like mainly about me going to see like different concerts and about my cat. So, if you are interested in my cat, maybe you can follow my account. And so the beginning of the story, so the reason why I started to learn about quantum computing is I joined the Advancing Quantum Architecture Research Group at Keio University SFC in 2018, when I was a freshman, when I was a first-year undergraduate student. And the reason I joined this research group is before I entered Keio University, I was interested in programming, just pure classical programming, and I was also interested in machine learning. And I thought it was a good idea to join this group because I can do something about quantum machine learning, and which allows me to know about some new knowledge, which is about quantum computing, and also I can learn something about machine learning and programming. And in addition, I can also conduct my research in English because Professor Van Meter, who is the supervisor of the seminar, is from America. So I joined this research group in 2018. And after I joined this research group, here are my main experiences in quantum computing. So like the lines, the sentences in blue, they are the activities that are related to Qiskit. So you can see that I have take part in some like IBM Quantum or Qiskit events right after I started to learn about quantum computing. And also I have graduated in 2021, and I have wrote my bachelor thesis related to quantum machine learning. And also in this year, as I said, I became a Qiskit Advocate in July, and now I am working on my bachelor, working on the project for my master thesis, so which is about generating arbitrary logical quantum graph state with lattice surgery, and this is mainly about like related to the field of quantum error correction. So about the motivation, so why I want to become a Qiskit advocate. So the first reason is because I am a Qiskit native. So as I said, like my native language is Chinese, But in quantum computing, Qiskit is my native language because when I first learning about quantum computing, the material I used most often was the Qiskit textbook. And the first programming language or the first platform or the tool I used to do some research or to do some experiment in quantum computing is also using Qiskit. So I have learned a lot about quantum computing from implementing quantum circuits using Qiskit. And the second reason is the people in the Qiskit community. So in 2019, I have participated in Qiskit Camp Asia, which I will talk about this later. So during this event and also during the process of learning about quantum computing when I was a beginner, I have received a lot of help from the people in the Qiskit community and also from the people of IBM Quantum. So I decided to be one of them and to contribute more to the community. And this is about my how I became a Qiskit advocate or how I got my 20 points. So I have categorized them into three categories. So the first one is research paper and academic project using Qiskit. So about the paper I have published, and also as I said, I have done my bachelor thesis related to quantum machine learning, which I also use Qiskit for this in this project. And also I have participated a lot of IBM Quantum and Qiskit events. So I think this is the main part of my of my 20 points. And the second category is the contribution to Qiskit community. So and because I have worked as IBM intern twice, and which I will talk about this later. And also I have I have write some article and posted on my blog about IBM quantum events. And also I have translated the Qiskit textbook into Chinese. I think this is the other part of my contribution. So the first part is about my first formal Qiskit event. This is the first formal one because before this I have also used the previous IBM Quantum Challenge as as the learning material. So right after I started to learn about quantum computing, which is in 2018, and Professor Vermeter has provided me the chance to take part in the Qiskit Camp Asia 2019, and which I have done a project that is about my interest. So it is about using the classical deep learning method to improve the compilation or to improve the building the quantum circuits. And I think what I have learned from this project is that even if you don't have you are still not an expert in quantum computing, you can also actively participate in the event related to Qiskit and quantum computing, because you will learn a lot from this kind of events. So this is what I found in this event. And another I forgot to mention that I wrote tier 1 and tier 2 and tier 3. This is just my guess, so I'm not confident in this, so this is just my guess. And another contribution is I have wrote a research paper as co-author, and this is a joint research project between Keio University and NICT, and the motivation of this paper is to investigate how resilient the classical cryptography algorithms are against quantum computers. So specifically, this project is also done using Qiskit. So we have run different size of discrete logarithm problem, which can be used to factor like large integers. And we have run the size of 2-bit and 3-bit discrete logarithm problem using Qiskit and run on the IBM backends to see that which size of the problem can be seen as solved, and which size of the problem cannot be solved by the near-term device. So in the other word, we have tested the scalability of the discrete logarithm problem, and we have so my contribution to this project is I was in charge of optimize the circuit and run the different size of the circuit on the using Qiskit on the IBM backend. So as a result of this paper and of this project is part of the 2-bit discrete logarithm problem can be seen as being able to solve by Shell's algorithm, which is a very famous algorithm in quantum computing. And some of you may know that 2-bit is actually a very small size. So we can know from this that is that like the noise in the near-term quantum computing quantum devices actually affect us, like actually prohibit us to solve like large size of the problem. So in order to achieve the so-called quantum advantage, we need to have a more like larger size of quantum computer that are more tolerant to noise. And another contribution, and I think this is a tier 1 contribution, is the contribution to the Qiskit community. So in last year, I have worked as a Qiskit an IBM community intern to help develop the IBM Quantum Challenge 2021 fall. And what I have done is I was a member to develop the final challenges, the challenge 4 with Bo Yang-san and Hyosok-san and Kifumi-san. So our job is to develop this problem and to support the challenge, to answer the question from the participants. So, and another thing that is like worth to mention is that I think one of the advantage of being in IBM being a Qiskit advocate is you can have the chance to support this kind of IBM quantum challenges. For example, in last year when I was doing the internship, I got the chance to support the IBM Quantum Challenge 2021 Africa. So which means I got the access like before the participants to the exercise, so I can test this exercise and to learn about this exercise. And what I have done to support the challenge is I answer the questions from the participants in the Slack channel, and I think this is a very meaningful work, and you can also learn a lot from it. And I really got a sense of achievement from supporting this kind of events. So I think this is another advantage of become an Qiskit advocate. And here's another thing I have done during my internship. This is the blog post I wrote for IBM Quantum Challenge. So I think writing this kind of article is it's really not that hard, not as hard as we expected. You can just write it from your view. So I have wrote the article about why should beginner in quantum computing participate in the IBM Quantum Challenge event. And another Another contribution is I have joined the Qiskit documentation localization team. I have translated some of the Qiskit textbook into Chinese, and I really hope that people speak Chinese can more involved into like using Qiskit and more involved into the community. And this is one of the omake because this is the project I have done in this year, which means after I became a Qiskit advocate, it's about develop and implement a frequency-aware qubit layout algorithm. And the background is, as I said, because quantum computing, as we all know, it has a lot of advantages, but it still has some like disadvantage. For example, it has some noise, and in order to make it make the quantum circuit run a quantum device with higher fidelity, we need to solve that kind of frequency collision, solve the kind of problem called frequency collision. And as a result, I have made a pull request to Qiskit, and it is still work in progress. And I hope this can be published later. So the last thing I want to share is about preparation for Qiskit developer certification. And as you can see, I have scheduled the exam very with very limited time. So gilly, and I passed the exam right before the deadline. But here's some materials I found that are very useful, and I found a lot of them are written in Japanese. So I hope that like the effort that people in Japan made can be more can be known by more people. And I think if you prepare well, if you have more time to prepare, passing the exam is not a hard thing. So here's some tips for becoming a Qiskit advocate. So the first one is actively participate in Qiskit and IBM quantum events. The second one is contribution to Qiskit. And the third one is optional because I think it is not replicable by some people because some of you might already be expert in some other field. So you don't have to be like experts in quantum computing, and all you need to do is like familiar with Qiskit and make some contribution and take part into the events. And that's all. And I am wearing this sweater I got from the Qiskit Camp Asia, and I also got this. I really like this, but you can see it is broken by my cat. Thank you so much.